Welcome to The Explainer. I am so thrilled to have you here today. Listen, if you've ever felt a little intimidated by chemistry, just take a deep breath and relax. We're going to look at the chemistry of the everyday world, starting right in your very own kitchen, and we'll build that all the way up to concepts you'll definitely see on your next science exam. We're breaking down acids, bases, and salts into a really fun, easy-to-grasp lesson that is absolutely going to transform how you see the common items lying around your house.
Okay, let's dive into this. Here is our roadmap for today. First, we'll meet the acids. Then we'll flip the coin and meet the bases. After that, we'll use the indicator test to tell them apart, which leads us right into neutralization and salts. And finally, we'll wrap the whole thing up with a quick exam revision.
All right, first up, meet the acids. Think for a second about the tangy foods you eat every single day. You know, like the sharp zip of a lemon. Well, you are literally experiencing chemistry right there on your tongue. The defining physical trait of acids is that they taste sour. Now, a quick friendly warning from your teacher here: while it's totally fine to taste the natural acids in your food, obviously you should never, ever taste chemicals in a laboratory.
You know, what's really fascinating here is how this just proves chemistry is happening all around us. Different everyday substances contain completely different types of acids. For instance, the tomato sauce you dip your fries in, the oranges you snack on, the lemons in your lemonade, they all contain citric acid. The milk sitting in your fridge, that's lactic acid. And that bottle of vinegar in your pantry, that is actually a solution of acetic acid. You are interacting with these chemicals every single day. Now, aside from being sour, acids share another absolutely vital physical property. Pretty much all acids dissolve easily in water. Think about that citric acid in your lemonade or the acetic acid in vinegar. They blend right into water seamlessly. This solubility is a key characteristic you're definitely going to want to remember for your exams. Moving right along, let's meet the bases. So let's step out of the kitchen and take a quick walk to the bathroom or the laundry room. Because if acids are the sour chemicals of the world, bases are their direct opposites. Bases taste bitter. And again, while you definitely do not want to go around tasting them, this bitter taste is a fundamental property that separates them from those sour acids. Where acids kind of dominate our foods, bases completely rule our cleaning products. Just look at these household items and their chemical names. Your liquid hand soap, that contains potassium hydroxide. Your solid bar soap and your laundry washing powder, those both contain sodium hydroxide. Baking soda has a base called sodium bicarbonate. And those really strong household detergents under the sink, they contain ammonia. Different everyday items use different bases, but almost all of our heavy-duty cleaners rely on basic chemistry to get the job done. Okay, mental highlighters out, folks, because this next bit is an absolute exam favorite and a really common point of confusion. We learned a minute ago that all acids dissolve in water, right? But what about bases? Well, some bases are actually not soluble in water. The ones that are soluble get a special VIP title. We call them alkalis. So the sodium hydroxide in your soap dissolves in water, meaning it's a base, sure, but it is also an alkali. Just remember this golden rule. All alkalis are bases, but not all bases are alkalis. Next up on our roadmap, the indicator test. Since we obviously can't safely taste lab chemicals to tell them apart, we use an indicator test. There are plenty of complex ones out there, but the simplest one uses litmus paper. So here is the ultimate conceptual anchor for your exams. Acids turn blue litmus paper red. Just think of acids as angry, burning red. Bases, on the other hand, turn red litmus paper blue. Think of bases as cool, cleaning blue. B for base, B for blue. Keep that simple little color association in your head and you'll literally never get it wrong. All right, so we've seen the red corner and the blue corner, the sour and the bitter. But here is the million-dollar question. What exactly happens when these two chemical opposites collide? Let's dive into the more advanced chemistry portion of our explainer. And that brings us to neutralization and salts. Welcome to the climax of today's lesson. When an acid and a base react with one another, they undergo what we call a neutralization reaction. In plain English, the extremes of the acid and the extremes of the base just completely cancel each other out. They neutralize one another. And the product of this epic chemical battle, it creates a salt and water. Let's see how this builds with a real, everyday chemical equation. Say we take hydrochloric acid, which is a very strong acid, known as HCl. We add it to sodium hydroxide, a strong base, known as NaOH. When they react, they totally neutralize each other to form sodium chloride, which is NaCl plus water. The acid and the base are entirely neutralized. And do you know what sodium chloride is commonly known as? It's just regular everyday table salt. Now, a quick aside, in chemistry, salts aren't just the stuff we sprinkle on our fries. Different salts taste different, and just like bases, salts actually have different solubility rules. They basically come in two types, soluble in water and insoluble in water. Our table salt, sodium chloride, easily dissolves in water. But another example of a salt is calcium carbonate, which you probably know as chalk. If you've ever tried to wash chalk off a blackboard, you know for sure that chalk is insoluble in water. In this fact brilliantly illustrates the power of that neutralization reaction we were just talking about. If we use our litmus paper indicator test on a salt, what happens? Absolutely nothing. A salt won't turn red litmus paper blue, and it won't turn blue litmus paper red. The color of either paper remains totally constant. Because the acid and base perfectly canceled each other out, the resulting salt is completely neutral to the indicator. All right, let's bring it all home with a quick exam revision.
We have covered some fantastic ground today, going straight from the kitchen to the lab. So before the proverbial bell rings, here is your ultimate exam cheat sheet. Let's run through it real quick. Number 1, acids taste sour and turn blue litmus paper red. Number 2, bases taste bitter and turn red litmus paper blue. Number 3, remember the VIPs. Bases that dissolve in water are called alkalis. Number 4, an acid plus a base triggers a neutralization reaction, giving us a salt and water. And number 5, because they are neutralized, salts have zero effect on litmus paper colors. Seriously, keep these 5 core concepts in mind, and you will absolutely ace those chemistry questions.
And that brings us to the end of our lesson. So now that you know the fundamental secrets of acids and bases, I challenge you to look at your world through the eyes of a chemist. Check the labels on your favorite snacks or your bathroom cleaners. What hidden chemistry is sitting right there in your home today? Thank you so much for hanging out with me for this explainer. Stay curious and keep learning.